The brothers Wisp. The brothers Wisp, brothers Wisp. The brothers Wisp. The brothers.
You're now listening to Greg, it's the Brothers Wisp. Let's take a ride through space on this mothership while you
Hey guys, this is Tommy, just giving you a quick pre-roll for our sponsors before the cast. The Brothers Wisp is brought to you by Sonar, a scalable, intuitive, and comprehensive ISP billing and operational support system. Learn more at Sonar.Software. We're also brought to you by TowerCoverage.com. Tower Coverage is your RF propagation system to empower your network, real-time data metrics, enable your coverage area, reaching your customer base, and more. The industry's best RF propagation mapping system allows website integration for customer sign-up and pre-qualification. Use this data to scientifically plan network expansion and help your WISP succeed. Get a free trial today at TowerCoverage.com. Quick note, with today's subject of the cast, I want to say that Tower Coverage is the benchmark to measure other competing products against. I have spoken to Dennis quite extensively about his services, and I believe they've made a solid product. We're also brought to you by Preseam. Get a single pane of glass view of your network with Preseam's trusted QoE solution. Using Active Queue Management, Preseam is a set it and forget it tool that lets you manage your network proactively without any complicated rules or geek knobs. With Preseam, you also get exclusive RF scores and analytics that show you the health of your network across all subscribers, access technologies, and vendors. Premium QoE, precise data, Preseam. We're also brought to you by Villo, a complete mesh Wi-Fi hardware and remote management solution that empowers WISPs of any size to delight your customers, reduce your operating costs, and grow your business. Designed with input and feedback from the ISP community, Villo is proud to be a trusted partner of over 150 ISPs around the world. Honestly, guys, the Patreon page is a big support, and the guys there have been really helpful, especially the last few months, with a lot of things that helped me along. And if you guys throw us a couple bones over there, you can join in and get access to the Slack group. And there's a ton of really smart guys there that honestly have helped me with every aspect of my network engineering career. And I would say that I would not be the network engineer that I am, or have the role that I do, without all the smart, great guys that have contributed greatly. And so everybody in the Patreon group, I really thank you, and you would encourage anyone else to get the benefits that you can get there. And on to the show. Hey everybody, this is Tommy with the Brothers Wisp. I'm here with Seth. I apologize, I didn't catch your last name. It's Poche?
Poche, yeah. It's,
Poche.
from Louisiana. It's Cajun name.
All right. Well, that Cajun with the French influence. So, who are you with?
So I'm with Cambium Networks, and I work on the global services team, and work specifically with cnHeat as kind of a development lead.
Okay. And then below me here, he's not doing any video because he has a voice for radio and a face for radio as well, is Andrew, longtime little brother and first time big brother contributing to the everyone in general. So Andrew, where are you based out of?
I'm the owner of a small WISP in Missouri.
Nice. And how long have you been WISPing?
A little bit over a decade. Formally
Okay.
for 13 years now.
Congratulations. All right. How big of a network are you running?
A few hundred customers. We cover, I think, a few dozen square miles. I'd have to double check that, but yep, small network. Nice.
All right. Well, today, Cambium reached out to me and was like, hey, we really want to talk about how cnHeat is a useful tool and can be useful for BDC deployment data. And I guess really, there really isn't other countries with similar reporting requirements, is there, Seth?
Not yet. I want to say there was one other country that kind of came up and was asking us about. I think maybe Canada was something very similar. Maybe it might have been a grant or something that they were applying for, but yeah, so far it's just the U.S. and I feel sorry for any other countries that have to do it. It's painful.
Yeah, by and large, I know the EU has some reporting stuff, but nowhere near as in depth. And my understanding is it's much more similar to the classic 477 stuff. And so I guess for network operators in general, BDC is a pretty big issue for us to be dealing with in how do we approach and how do we handle, because there's two main ways of submitting your data, and that's with location data, and then also Polygon, which is really beneficial for WISP because if we have all that information, we can contribute that and make that work out, and it's a lot simpler than doing the location data, is my understanding. And it gives you much more accurate views of where your actual coverage is. So how long has cnHeat been out? I've never used it personally, but it's been a couple of years since I've heard it coming out in the waves.
Yeah, I mean, we started early 2019, and it really just started as an idea. We knew that we needed to do something better as far as predicting coverage, at least for our radios, and now we've moved on. We support other radios as well. And so we started in 2019, and it was just this revelation that if you have a very accurate underlying kind of model to work from, then you can also produce very accurate predictions as well. And so kind of progressed from there. It was slow starts. It was a lot of crawling and then walking, and hopefully now we're getting closer to running. But and then the 2.0 version, which came out about a year ago now, it's the self-service. It's the kind of the one that people kind of know. So before that, people probably didn't know about cnHeat. It probably wasn't that useful, but yeah, about a year, I guess. Okay,
so the modern version. And so my understanding is I recall from the very beginning, it was a lot like the Ubiquity tool, and that almost everyone has used. That's where I cut my teeth with RF propagation modeling in an extremely optimistic viewpoint.
That's right.
So that's kind of my understanding where a lot of guys are starting off, and kind of what my understanding of the CN is. It was very much Cambium focused, and had a lot of just generalized assumptions. My understanding, though, now is that new cnHeat 2 really broadens that, and then brings in a lot of very accurate data. So what would the differences be from the Ubiquity tool that everybody's used to what cnHeat's offering?
Yeah, so the most traditional tools, and I think this includes Ubiquity, tend to use terrain data. This is bare earth, and that data set is generally pretty available. It's not too hard to find something that's going to do bare earth. And then on top of that, you can add clutter. And what a lot of tools choose to do with clutter is, and this is the traditional approach, is simulated data, where you say, okay, we can draw it on a map, this forest, and this forest is deciduous trees, and we believe that the heights are roughly 80 feet. But it's really simulated. I mean, if someone comes in and clear cuts a portion of it, or a storm or a fire comes through, it doesn't really accurately show the full picture. And that's the biggest difference with cnHeat, and also the strongest, our biggest strength is everything we do is based on LiDAR data, and it's a scan of the real world. So an airplane is flown overhead, lasers are pulsing out hundreds of thousands of times a second, measuring the heights of everything. And with that, we're working off of a true model of the Earth rather than simulated data. So that's the big difference.
Okay, and then so what kind of accuracy are you guys working with?
The LiDAR itself tends to be within centimeters, and what tends to get collected is usually 10 points or so for every square meter. and it tends to be an accuracy height-wise of just 2 or 3 centimeters. So we're talking like an inch or two height accuracy. It's in a point cloud format, which is just all of these points floating in space. We have to convert that to be able to process it for RF propagation. And when we do that, we down convert to 1 meter resolution, and that will tend to kind of skew the heights a little bit. And then also things change. LiDAR is incredibly expensive to capture. I've heard I've gone to some of these trade shows, GIS trade shows, and they say to get an airplane in the air, it's $1 million, just to get started. And so it's very expensive, which means it isn't collected that often. And so that can cause problems. I mean, trees grow, trees fall. So that adds a little bit of error. But in general, I think we tend to be within a foot or so of all of the obstructions, even with all that put together.
Okay. Yeah, that's pretty similar to other products that I've interacted with. So then so from there, you've also expanded into being able to handle a lot of different antenna types and radio types nowadays. And so like you understand, and then I believe you have a pretty wide frequency range, because as everyone knows, 2.4 will go a heck of a lot further through various things, particularly trees, than 5 gigahertz will, or even the higher frequency stuff. So what kind of frequency ranges of radios are you guys handling?
Yeah, today we're 2.3 or 2.3 gigahertz up through 7.1. And then we break off and we do 28 gigahertz and then also 60 gigahertz. We're looking at adding 900 megahertz. That's a popular band, especially for some of the harder to reach places. And but we need to do a little bit more modeling there, make sure we're putting out something that's accurate.
Okay, well that's really cool, because I I know that I actually have a few customers who are still running 900 megahertz just because they're in the middle of a forest, and that's the only thing that's going to get to some of their customers. And so being able to get a good estimate of what that looks like, especially and he's a one-man show, and so if he can know what he's getting himself into before he gets over there, and then do you guys like have a general list, or is it just like, hey, you can build your radio and then save it, and whatever that is, you can bring, you guys can build whatever their network is built out of?
Yeah, I mean, we try to keep it pretty simple. When you go into cnHeat, you can set up a project, you can set up sites, and then under sites you add the radios. These are your tower sites.
Mm-hmm.
Under the tower sites, you can add radios, and when you add radios, we're trying to ask as few questions as possible. So we need to know the antenna, because the antenna that you're selecting will affect how it propagates as far as antenna pattern. And then we're asking for transmit power. We want to know what direction it's facing, so it's azimuth and elevation. And then we also, because we're doing link budget calculations to try to determine the signal strength at the far end, we also need to know the gain of the subscriber module or the CPE. But other than that, we're not asking a whole lot of questions. And so that gets us from point A to point B without asking too much and being too burdensome.
Okay. So as far as like antennas go, like what's your list, Jane? Do you have RF elements?
We have RF elements.
Okay.
Cambium, of course, Telrad, Mimosa, Radwin, Tirana, Ubiquity, KP Performance, Alpha Wireless. If there's a way for us to get our hands on the antenna pattern, then we're happy to load it in.
Okay, cool. So shoot, I'm trying to remember the Elcom. No. Yeah, there was one antenna manufacturer I used to use for C5Cs back in the day, and they were really weird, and so I would love to see what that pattern actually looks like out in the real world. But I mean, those are all the major antenna manufacturers. I can't think of, besides the CPE antennas weirdos that I use, any of them that you guys don't cover. So that's really the big ones. So Andrew, have you found that the 2.0 is pretty intuitive and straightforward to use?
Yes, yes. I started using 2.0. I've not used 1.0 at all, but I jumped in approximately 6 months ago using 2.0, and there was a little bit of a learning curve. It took some time to go in, put in our tower sites, fill out all that information, but it, it's not that much. I do feel like it is the minimum required to be able to build an accurate model, and it's just one of those things that needs done.
So what would you say is like the time it takes for you to put that together for a tower? Let's say standard tower, 6 radios, and a point-to-point.
Oh, I was doing that in under 20 minutes. First time, definitely under 30 minutes.
Okay.
Probably quite a bit less than that.
And then from that, so what kind of radios are you using?
Almost completely Ubiquity.
Okay.
AirMax AC.
And then what are your antennas that you use?
We're mostly using RF Elements asymmetrical horns now.
Okay. So yeah, those probably all just plugged in and come out with really pretty patterns, actually.
Yeah. And right away we noticed that we didn't really have to change many knobs. We just put in what we had and found that it very closely matched our real world testing from the past.
Okay. All right. So when I have mapped out antenna patterns out into the real world, usually that was either with the Ubiquity tool or for longer term projects that I needed to do for Colorado mapping requirements. Because they are very similar to FCC BDC. They didn't have location data, but if you were wireless, you had to show, hey, this is what your coverage looked like. So for that, I started actually when building that out in Google Maps, we really noticed some pretty severe dead spots and like, oh, this is why we've never been able to pick up these customers. Because what I was doing is actually climbing up and measuring, because for years and years, there'd been no one who'd kept track of exactly where things were pointed. It was one guy who'd thrown all the radios up and just as he'd went along, built stuff. So did you have pretty good documentation beforehand going up, or did you have to kind of build from scratch?
Honestly, we're a small enough network that I was able to build most of that from memory. Like I knew what landmarks I had aligned most of the sector antennas at, or on some of them I did have actual documentation of azimuths or landmarks. Okay. So it was a combination of documentation and memory. I think we had to do one tower climb to verify like azimuths on a couple of sectors, but another thing that we were able to do was compare signal strength on clients on the edges and tell within a few degrees of where the center of a sector probably would be.
Okay. So I guess there's probably a bunch of different ways to skin the cat. So you were saying you were doing this just about 6 months ago. How long would you say your project took for you to enter it all into cnHeat and then get it ready for submission for BDC 1?
All told, I mean, it was full days for about 2 to 3 days, but I did quite a bit of massaging of the data. Now, I did not submit the polygons that cnHeat creates. I pushed my data through QGIS. That had been my workflow for over a decade with the Form 477 filings. So I was able to bring the cnHeat coverage output layer into QGIS, and I had my existing census blocks, which weren't really that useful, but then, I brought in the fabric addresses as a layer into QGIS. One of the main reasons I wanted to continue going through QGIS is, well, our previous coverage data, I would guess, is approximately 50% accurate. In some cases, it was, when I say existing, this is prior to cnHeat. it was probably more overstated than understated. And so we were doing a lot of masking. Like I would have a mask layer in QGIS and say, oh, I know we don't have coverage to this group of homes here, even though our coverage projections show that we do, and vice versa. Maybe we had not done coverage projections for a micropop, but I knew we had coverage there, so we would draw that in as an inclusion layer. And so we still had to do a little bit of that here and there with cnHeat, but it really cut down the time to do that process. We started with, I would guess, a 90 to 95%, probably a 95% accurate starting point. And we had very little masking. And mostly we were just including specific things where maybe I'm shooting under a tree where cnHeat's LiDAR data doesn't happen to know that there is a gap and there really is one. Or frankly, we had a few micropops that we did not include in cnHeat because of distance limitations or things like that. So, we were more including things that cnHeat did not know we had coverage of than the other way around, which is exactly how I wanted it to be.
Okay. So Seth, is that kind of like what your guys' goal is? Get it so guys can get their information done in the last couple minutes before BDC.
Well, we definitely don't want people waiting to the last minute, but just from a accuracy perspective, I mean, there's tons of tools out there that have been plenty good for years, and we weren't interested in just the Me Too product. We really wanted something that was going to kind of change the landscape. And we got into it at the same time when a lot of other companies, I mean, now there's 3 or 4 kind of options of this kind of high resolution. I mean, it really has kind of been a mapping revolution in a sense that we just weren't able to do before. And so this is the hope, is that customers can go in, they are getting more accurate data. And then also hopefully it's not too painful. We try not to make it too difficult. We don't always succeed, but we want it to be a simple process for customers.
Okay. So then moving from like what that so Andrew is like massaging and having to do that because he doesn't have all the data, and there's data that just is impossible to have. Or could somebody take their outputs straight from cnHeat and spit it right into the BDC reports?
Yeah, and that's a great question. If you watch some of our training videos, we actually need to go and update them. When BDC first came out, there was a lot of confusion. They kept updating the specification all the way past the deadline, or right up into the deadline, and so we were guessing kind of as much as anybody. We really pushed hard that the polygon method is the right way to submit. What we thought was this is the truest representation of your coverage, because we knew that the fabric data wasn't going to be good to begin with. And so why not just submit your coverage, and if the fabric changes, it changes. At least you submitted your coverage. And then a week before filing, the FCC put out a workshop, and they were talking about everything. And they basically said in this video, they said, if you submit polygons, we're going to take the polygons, we're going to overlay it with the location fabric and use the locations. And it was kind of like, well, what are we doing? Why are we going through all the extra effort? And the only saving grace is a little bit later in that video. They said, if you take a polygon, you upload it to the BDC portal as availability data, there is a section to the right where you can actually download the locations, and they'll be encoded with all the information. And so it is nice. I mean, I can tell you, Andrew, his mind is a steel trap. He knew his network. He is very precise, very detail oriented, but he's definitely the exception more than the rule on that. And so for people who aren't as used to doing this kind of technical stuff, you can just take the polygons from cnHeat, upload them as availability data. There's a spot once you upload it where you can download the location list. It's an overlay of your polygons with the fabric, only showing the ones that are covered. You take that list, it's a spreadsheet, you delete out 3 columns, latitude, longitude, and submission job ID. and save that. Then you delete your polygon, pretend like you never uploaded it, and upload that spreadsheet in its place. And so that's a way you can do a location filing using the cnHeat polygons and not have to do all the extra work of going through and listing all of your radios and where they are and what heights and all that.
Okay. All right. So there would be some advantages with that route. And especially like you can now know what what the FCC will see after having massaged your data that way that they would have. So from that, I guess my understanding is a lot of the RF propagation theory, I've owned a ARL handbook since I was 16. That was Christmas present for when I turned.
Wow.
Yeah. So we've had the RF theory kind of figured out for quite a while, and exactly like how that boils out. And we can understand, but that changes, or we haven't really been able to have the data that brings that in and utilize that. And also really data communications back when I was 16 just was not where it's at nowadays. I mean, the ability to, with 17 dB SNR send, hundreds of megabits worth of data, that just didn't exist. So how do you, account for like what speeds you were going to be able to see, especially over a pretty like wide range of capabilities in radios? Like how do you guys calculate that out?
Yeah, so the short answer is that we don't. So what we're doing is we're predicting receive level, and then we leave it for the user to map its receive level to the speed. And I think that's something that WISP operators do already. I mean, they say don't go to this customer and install unless you get an x66. They signed up for a 50 meg package or whatever it may be. So we're not trying to get into, I mean, it could be overwhelming pretty quickly to know how one radio operates versus another, especially just minor changes that you can make in the radio, like changing the frame rate or, the size of the frame, or changing the channel size or things like that. So we try not to get into that. Rather, we try to predict the signal strength and leave it for the operators to do that conversion. And that saves us a lot of headache.
Yeah, that would be a lot of compute and a lot more questions to ask too, I guess. So then what are you doing the calculation on as far as channel size by default? Or do you just let the operator say, hey, it says 20, this is a 40? So what are those two options do you guys give?
Yeah, I mean, fortunately, most of the bands that a typical WISP would operate in, they're limited in such a way that there is a power density, and so many milliwatts per megahertz, and so the signal level stays the same in those cases where whether you're running at 20 megahertz or 40 megahertz, ultimately your receive is the same. Now the receive sensitivity changes and what you need to be able to meet those certain modulation rates, but that helps in that situation. And then for the more advanced users, I mean, they can always kind of back out the power in cnHeat, or progress the power, give it a few extra dB of transmit power to compensate. But that's where we kind of rely on the user to hopefully understand what they're doing.
Okay, so definitely the more knowledge you bring to the table, the more benefit you're going to get out of the tool. That comes for hammers, which are about as simple a tool as you can make, as complicated a tool as measuring RF propagation across unknown terrains and random terrains. So Andrew, you were saying that you were pretty close. Like how close were you seeing for your equipment?
I'm more talking about physically close in terms of being within maybe a few feet of where we would put a receiver antenna and expect there to be coverage. That varies a little bit depending on tower. Perhaps we don't have our GPS coordinates perfectly accurate for some of our antennas, but here and there we're seeing maybe a sliver of coverage, like shooting down in a gap between a couple of trees. In some cases, it's within 2 to 3 feet of where we installed the receiver antenna on the building and had peak signal strength. In other cases, it may be that sliver that cnHeat shows maybe about 10 to 15 feet away. So I think that may be bad data points on our part, but with almost without exception, it reflects what we saw, as in if we had a really narrow sliver of reception in between a very narrow gap between trees, if we saw that during the installation, cnHeat models that as a very narrow sliver of coverage hitting our customer's building. If it's a bit wider, then cnHeat models that. I would say in most situations, we're seeing it within about 5 or 6 feet of accuracy in terms of height off the ground and left to right directions on the building. We're able to pretty closely do a reverse prediction of where our receiver antennas of existing customers are installed on buildings by looking at cnHeat and where it models coverage in our existing network.
That's closer than really I ever got. I was never within 10 feet of it's somewhere on this side of the building, unless I had done the install myself. And I'd be like, oh yeah, I dropped it right here on this peak right here. So then I guess maybe to clarify, I'm assuming you're not on the Great Plains of Missouri.
We are in a hilly, mixed forested terrain. And land cover is the biggest thing for us. The biggest weakness of any coverage tool I used before cnHeat was the poor land cover data.
So then this pretty much just changed up exactly how you approached all of your modeling. I'm guessing.
Yeah. LiDAR is absolutely a game changer for us. There's one interesting example. We've got a tower that's only 30 feet above ground level, and it's along the edge of a forest. And the trees are taller than 30 feet. So any previous modeling tool that I used showed that land cover data covering the location of the tower. So it would model it as if the tower was in the middle of a forest. Well, it was backed up against the forest, but we had 180 degrees of real world coverage off of it. But modeling tools would show that we had no coverage if we used clutter data on that tower. So we had to completely disable the modeling of land cover and subsequent hit that you take per meter of forest in the 5 gigahertz band. And cnHeat with LiDAR data changed that for us.
So what would be where your installs are and where location wise very accurate, have you been able to largely meet or exceed what cnHeat was saying you were going to be getting?
We use cnHeat primarily as a tool to figure out if we should expect line of sight or not. We're not using it closely to model receive signal levels.
Okay.
I'd say we're mostly using it within 2 to 3 miles of our towers. So it's not as big of an issue anyway. We're close in, and if we have line of sight, we're going to have good reception. So yeah, we're not watching that so much as whether we have line of sight at all or not.
Okay. And about how far out do you generally install your customers?
We try not to push it more than about 6 miles. Although if we can get a tower within 3 miles of our customers, all the better.
Yeah, that 3 mile mark, it just, once you go above that, you really do have to get serious on aligning your antennas and making everything go well. I can throw up a power beam basically blind and within 3 miles and make everything work. I had an installer who would do that, like in town, less than a half mile away, instead of placing a radio not through without a tree blocking it, he would just throw a power beam up just because. It's like, well, he won't be, he wasn't caught because he's on the other side of the network, and I'm rarely over there. Until I was.
You had an installer. I noticed the past tense there.
Yeah, it was a past tense. He was replaced.
Yeah,
because
yeah.
you can't be doing that. So then, Seth, what would you say would be other benefits that cnHeat brings to the table for guys? Like, okay, I can submit my data, I can know where I'm going to be can install. What would be other kind of use cases and ways in which you can improve your network, management? Because that's what it is, a network management tool.
Right. So, we started out as a pre-qualification tool. That was our number one focus. It was the thing that we cared about more than anything. And you can see it in the software. I mean, you look at the software, it's the things that are easy are the things like doing customer lookups. We would like to move more and more. I think there's a lot of value moving towards the engineering side. And so there's a lot of focus this year on trying to make features that will allow planning better, because if you can accurately say whether one customer is connected or will be serviceable, then you can also use that same kind of model to be able to say, is this a good tower location? What's a good RAD center? What kind of gear should I be deploying? And so that's kind of our next goal here, is to try to expand out that aspect. And we found that's that's where we get beat up the most by customers, is they come to cnHeat, the pre-qualification is great, and then they want to do planning, and they usually have some feedback for us. Why didn't you make this easier? So we're working on that, and I mean, it really is kind of a whole new world with the LiDAR, as Andrew mentioned. It's a game changer. I'm excited for the things that we're going to be able to do as an industry in the coming years.
Okay. And so, like, is there a way that, or I guess in like when I'm envisioning planning stuff, you would let me like say, okay, here's a bunch of houses and here are possible tower locations. Tell me, is that kind of where you guys are aiming to go?
Yeah, we hope to get there. We started out in the early days. We actually had a tool that you would put all the customer locations in, and then we would do a reverse heat map and show you where is your single best place to put a tower. And so we would like to kind of get back to that. That was kind of some R&D stuff that we're kind of having fun with. But I mean, yes, ultimately, yes, we have some work to do. It's, as we built out the tool, it's become more and more advanced. It's become harder and harder. The first time we ran a LiDAR prediction, it was line of sight only. It was out to 8 miles, and it was a static customer height. And it took us 3 days to process the LiDAR, to run it through. At that time, we're using ATOL, 3 days on the fastest machine. And now within, a couple hours, we can do an 8-mile prediction. We're doing line of sight and non-line of sight, and we're checking every customer height between 0 feet and 80 feet. And so the improvements that we made are pretty substantial, but it means it's a lot harder to kind of tweak things, and the shortcuts that we've had to take make it harder to kind of go and do something completely different. So it's a problem. I mean, like, it's a challenge, like a puzzle that we have to continually try to solve. And it's both challenging and rewarding and frustrating at times as well.
Well, that's what makes us all engineers, is coming in and like being like, okay, how do I put this tool in an efficient manner to, build this product? I think one of the best lines I ever had a customer telling me, he used to be a civil engineer, and he would build bridges up in the mountains. And I was talking to him about the David McCullough wrote the book about a bridge that was built in New York, and it was this really impressive and cool one. And I want to go visit, but I can't remember the name of the bridge right now. But I was talking about like the issues that they ran into, and I was talking to him about like just general engineering concepts and practices, and he says, fun fact, anyone can build a bridge. It takes an engineer to just barely build a bridge. And that's what makes, that's what makes engineering so cool and interesting, is that we're trying to build this thing that is actually efficient. You go, just throw enough parts and materials at something and eventually it's going to work and last forever. And so building something that is actually efficient, like I've heard some of the like compute requirements for doing this LiDAR compute stuff, and just you're hammering servers. What does that look like as far as just cool nerd factor?
Yeah, it's expensive. We got a call from IT back, I think it was the spring of last year, and they said, your AWS bill is going up by quite a lot. And they said, why are you storing so much data? And we basically, they were pointing to this fact that we had 100 terabytes of data sitting in a bucket, an S3 bucket. And they said, you need to get rid of it. It's costing us money. But that 100 terabytes was 10 days of LiDAR that we had processed. Like, it's a rolling average. It's 100 terabytes every 10 days. And it automatically deletes, and don't tell anybody this, but they didn't even see the other stuff we had stored. So it gets it is a lot. It's not a trivial thing to do, but and that's kind of the civil engineering part of it, is how to do it and do it efficiently, to make it actually work. So it's a lot of time spent on that aspect for sure.
So Andrew, have you tried to kind of besides customer mapping and where you expect to get a performant connection, what other utility have you benefited out of cnHeat?
Oh, the biggest thing would be just using it as a sales, maybe you could say pre-qualification tool, but it really cuts down on the time it takes for us to determine if a sales lead is a no-go. And that doesn't require me to look at it anymore. My sales guys can look at that. Pretty much anybody in the company understands enough to be able to pull up cnHeat and figure out, does this have enough potential? Does this warrant an in-person site survey? Does it warrant using some other software tools to figure out if there's a possibility or not, or is it a no-go? So, I mean, it's our first step. And for quite a few of our leads, it turned a 10 to 20 minute no-go process into a 30 to 60 second process. So we definitely save time on the sales side of things right there. And then if it does move on, if we realize it's not an immediate no-go and we schedule it for an in-person site survey, then it gives us more information for the installer at the time of the survey. He's able to go out there and understand a little bit about the clutter and how that's impacting the incoming signal from the tower. He's able to go out there and know approximately how far off the ground he's going to need to test at, and what part of the building is going to have the best reception, or whether we're going to have to mount the antenna off the building. We were using some other tools previously to go out there, but this LiDAR data has totally changed the accuracy of it. I mean, we're able to show up with a much better idea of where that antenna needs to go and do testing in that location.
Does that I would assume the LiDAR data also includes buildings, right?
Yes.
Okay. Yeah, because that was actually you mentioning the mounting an antenna onto a building. That was actually several times experiences that we had where it was like, well, it looks like we should be able to get you signal if we put a 30-foot pole here, or if you were to do something, but I can't promise anything. We'll be 60 feet up in the air. Don't have a ladder for that, and I can't test that. So being able to have confidence in that would have been really, really awesome, and would have changed. There were days I'd spent multiple hours modeling everything out, making certain that I got all the ground stuff, the antennas were at the right height, and then just to be like, well, it's going to be risky. We could spend a lot of money on this, but I can't make any promises. And so that's a lot of engineering time, because I mean, there would be back when I was doing WISP stuff, at least 1 or 2 a week, where it'd be like where I needed to go take a look and be like, is this someplace that we could be? And even for places like people like my CSRs, like they had access to our Google Maps, and that was updated once a year or once or twice a year for, hey, these are where we have customers. If we have customers nearby, it should be doable. But that there was very frequently like, hey, can we get this person? Can we get this person? And so having both the like, hey, yeah, we have customers nearby, and also the pre-qualification data that is pretty reliable would really actually change a lot. So that's and also make the user experience for sign up a lot better.
Yeah. It still requires some work to verify whether we can offer service to some people, but it has definitely increased the efficiency of that process for us. It's been a very handy tool in the bucket.
Yeah, anything to get people off of your back for questions is probably beneficial.
Yeah. One thing we run into is if we're trying to shoot a gap in between trees, we have to approach that differently than if we're shooting over the top of trees. So, if we're shooting over the top of trees, then we can pretty well trust that LiDAR data. Because in our area, it's pretty recent. It's going on 4 years old now. So we have to account for tree growth. But, in most cases, trees are not going to grow 30 feet over the course of a few years. So we pad in a little bit above what it tells us is necessary, especially if a customer's looking at investing a lot of money for a tower. We don't want to be 1 foot above where the tree canopy was 4 years ago and then have their service start getting intermittent almost immediately or a few years down the road. So we have to plan for that, of course. Whereas what we find that takes more testing in person to see if it will work or not would be if we're trying to shoot in between trees or under trees. There's definitely times where you can shoot under the canopy of a tree or a few trees, and sometimes LiDAR seems to see that, sometimes it doesn't. But it really is amazing just how much of an individual tree those point clouds can model.
Yeah, I just have seen the Google Earth trees that they've built up, and those definitely are less resolution than a couple points per square meter, and those are still pretty darn good. So then, Seth, you guys are looking at generating information for guys who are wanting to plan out a network and such. But still be very a useful tool for a sales guy who's not an RF engineer, doesn't want to be an RF engineer, and won't ever be an RF engineer. How do you expect to kind of balance that? This is like the eternal question of UI UX.
Yeah. I mean, it's a good question. I mean, it's today we're trying to do it with roles. I mean, we basically have an admin, a read write, and a read only. And by moving someone to read only, one, they can't change anything, which is good. But then also you can have things hidden. So you can actually have kind of what if scenario. You go to a tower and you say, what if we put CBRS on this tower? What will coverage look like? Well, you can hide that from a read only user. And so that's kind of the way that we're doing it today. I expect that as the tool grows, we'll have to put more and more along those lines to kind of, separate those two. But it's a valid question. It's something we're gonna have to work hard on to make sure that we're keeping it safe for the people who don't want to get into the weeds, and then we're also flexible enough and advanced enough for the operators that are really going after it.
Okay. So Andrew, what would you say would be your biggest, like, where would I love to see this thing move forward? Now's your chance, because everyone's listening.
I definitely want to see some more tools for predicting coverage. I want to see that best possible tower location where you can plug in multiple customer locations and it will show you a heat map of good potential tower spots. I would be interested in seeing something a bit longer range. There are times that the current 8-mile limit is a little bit limiting. I find myself right at the edges of coverage. Not so much because I'm wanting to see if it will work off of our existing point to multi-point sectors, but there's a couple locations where I'm interested in putting a new tower about 9 or 10 miles out from an existing tower, and I have to use other tools to model that point to point, and it'd be handy to just push that range out there a little bit, but I understand that increases the compute requirements a lot. So,
so Andrew, my apologies. We had our developers rework everything, and at WISP Palooza last year, we announced that we can go up to 12 miles now. So should have communicated that better, but you should be able to go in the tool and any of those macro sites, move them out to 12 miles and see it now.
Okay, so, I had not noticed that. Awesome.
Yeah, I'm sorry. I'm so sorry.
This is a time when being a Mike Hammett and complaining to the developers would actually have benefited you.
Well, I know what I'm doing this evening.
I'll watch the AWS bill.
Okay, so well, that's awesome. And so all right, I guess we're coming up on a bit of an hour. And Seth, what other kind of cool things are you guys looking at? And make it through BDC, and manage that. Don't crash the servers, please. No big updates in this next week, please.
Yeah.
But like in the coming months, what are we looking at?
Yeah, we are trying to make it through BDC at the moment. We also have an internal alpha version of something that a lot of customers have requested, is the ability to take the map view, put it on your website, have customers come and check coverage from there, and then that be a web lead. So we are on the verge. I'm hoping we can release it before WISP America in 2.5 weeks now. And the other interesting thing about that is you'll be able to take the map view and embed it into any web tool. And so you could embed it into an NMS or something like that, and you can control everything. And so you can imagine maybe you have a billing tool, and you want every time you go to look up that customer that it zooms into the customer, it's got the height set at 2 feet above the rooftop, it's got your predictions turned on. All those options have been disabled, so no one's going in and messing things up and confusing themselves. But that should be one of the advantages of this new feature. So that's coming out here, hopefully, fingers crossed, in the next week or two. And then after that, we're looking at trying to run heat maps just around specific customer locations instead of running them around the entire tower. Instead, you could just do a lookup. And so that's hopefully before the end of June, and then try to get some more API stuff and some more planning stuff in before the end of the year is our hope. Okay.
So I guess as like a little bit of a question on that, for the NMS, would the network management system for its API, when it's saying, hey, I'm putting in, it can say, hey, this is where the antenna is mounted in height and stuff. So it'll be able to tell the cnHeat what it should be, what to give back to it. Is that what you're doing? Or is it just this is a static set, what it should be?
Yeah, it's taking our map view and cnHeat, where you can turn on all the predictions that you've generated and look at the different coverage, and take that as an iframe and put it into something else. But then you can control it. It's it's got a token, and you can go through and control and turn certain features on and off, and then even control other features via like post parameters and be able to.
Okay, that's really cool. So I guess one last kind of question. You were saying that there's LiDAR data is very expensive to get, and out there, like Andrew was saying that his is a couple years old now. How often is this kind of data updated?
Yeah, it's a good question. So the aerial, and there's different types of LiDAR, but the stuff that we use is aerial, and it's almost always from an airplane. versus like a drone or something like that. To cover counties and counties, you just about couldn't do a drone. And that data in general, when it's captured, after it's captured, it takes what we see about 18 months to 24 months to process it and release it. So the absolute newest data, if you talk to anyone using LiDAR data and they're talking about how excellent it is and how new the data is, it's almost never newer than 2 years. So you have to kind of keep that in mind. And then in general, we see updates between every 5 and 8 years. And so, today, if they fly your area and they release it in 2 years, it will already be 2 years old, but it will be really, really good data. And typically we see anything within 5 or 6 years as being pretty recent, pretty reliable.
Okay, cool. Okay, well, if people out on the internet wanted to get a hold of you, Andrew, how should they bug you?
We've got a website for our WISP. It is ridgetopnetworks.com, or I'm a member of the Little Brothers WISP Slack as well.
Definitely. And you're there, and you're usually answering questions on Ubiquiti stuff and a bunch of other stuff. And now people will have a bunch of questions for you for cnHeat, I hope.
We'll be happy to help.
Yeah. And then, so Seth, Cambium Networks, I would hope most people know how to get to your company website. Do you have a Twitter where you blog or make the world a more crazy place?
No, I mean, we do have a community forum where we post things, but they tend to be pretty just practical, pragmatic type of, hey, if anybody noticed this, here's how to fix it.
Okay.
And if anybody ever wants to reach out, cnHeat at cambiumnetworks.com, that will get me, that will get our product line manager, and then also our production team. And so we can, amongst the three of us, we can answer just about any question, and happy to. We try to be as responsive as possible.
Awesome. Well, cool. So, and then will you be at WISP America?
I will be. I'm excited.
Yeah.
Louisville.
All right. Yeah, it's going to be in Louis. Andrew, you showing up?
No, not this year. One of these years I'll make it to a show in person. I've been saying that for a decade now.
All right. Well, we'll be there. I'll make certain to bug you, Seth, and everyone else. If you're coming out to WISP America, love to see you, love to catch you. And Tommy, lostcreek.tech, HTTPS only, because HTTP is still broken. I'm on the Brothers WISP. Occasionally I'm on the Mimosa forums. I'm on Facebook, all over the place. So reach out to me, bug me however you like, and tell me that I'm wrong, and I will prove you wrong. So, all right, guys, take care. And just for one quick for you guys, before I stop rolling here, I'll quick kill the roll.
It's networking. We talk about equipment and methodology, so sit back and start learning. Lighten up the tower so people can start searching. Shooting up the web in neighborhoods, net surfing. We got horrible jokes, we're loud and annoying, but we're informative facts, we're not disappointing. Just give us a listen, cause fun is the mission. I'm telling you, you don't know what you are missing. Ideas and some good comedy given. If you missed the show already, don't worry, you're forgiven.